This week we're going to look at Chapter 11, Authentication and Account Management. A couple things we're going to look at is the different types of authentication credentials, what a single sign-on can do, account management procedures for securing passwords as well. When we look at authentication, we can look at our username. That's saying who we are. And then the type of authentication we can use is to say prove it. So if we say our username and then we look at the type of authentications, some of these may be where you are, what you have, what you are, what you know, or what you do. Those are different types of ways to authenticate your credentials. For example, a key fob, maybe something that it's something you have. Biometrics, facial characteristics are something you are. Combination lock is something you know. Military base, maybe somewhere that you are. Push-ups are what you do. Those are different types of ways that we can authenticate our usernames, our credentials. So we look at what we know. This is going to be your most common type of way to authenticate. In this case, we're looking at passwords. So what this is, the user logs into the system. It's asked for their username, so they enter their username. So they're saying, this is who I am. And then they're asked to prove it. The way they prove it is by entering their user password. Now, while this is the most common type of authentication used, it also is weak protection. Ways we can increase the protection of this is to use stronger passwords. Some of the actions we can take with this to increase our security with our password is to use longer passwords, combinations of upper and lowercase letters, symbols, numbers, and all of this can be set in with our password requirements. The weaknesses of passwords you can look at is they're linked to our human memory. Okay, so we can only memorize a limited number of items. So while the long, complex passwords are the most effective way to increase our password security, they also become the most difficult to memorize. Also, it's recommended that users use different passwords for different accounts. So by using a different password for different accounts and having complex passwords, they do become more difficult to keep track of. Passwords should be unique for each account. And when we're working with our organization, the policies should mandate passwords must expire. And the weakness of this now becomes that the users must repeatedly memorize passwords. Users also often take shortcuts by either using a weak password, which is the examples of this would be a common word, short passwords, personal information. And they also have a weakness of while they're trying to create a stronger password, they generally follow predictable patterns. Okay, so that may be something where they append to the end of the password by changing a letter, changing a number, using the same punctuation in a pattern. Or they use replacing, so they will use replacements in predictable patterns. So appending, for example, if you use the word GNTC for your password, you may put a 1 on the end of it, or a exclamation mark. Replacing, they may use this GNTC as the password and then say the exclamation mark. The next one, they will use the @ symbol. So they're just using it in a predictable pattern. Every year, a list is put out with a link to password weaknesses as they rank the weakest passwords. And we can see on the screen here in 2018, this was the passwords that came out with the book. The number one password that was used, the weakest password was 123456. And you see the patterns are formed here. And this is why passwords are a weak form of authentication. Now, a couple ways passwords are discovered is through social engineering, either by sending a phishing email, shoulder surfing, or dumpster diving. Because passwords, once they become so complex, people tend to write them down, and then they take them and throw them in the trash, and then they're able to be found by dumpster diving. They also attacks of capturing using a keylogger or man-in-the-middle attacks. Resetting is also an attack on the password where the attacker gains physical access to the computer and resets the password. With a lot of online passwords, the resetting, they do not even have to have physical access to the computer. Okay, if your password, so you say your email is compromised, they can request password resets to other systems and then use your email to reset your password. We also have offline attacks. Okay, this is the method that's going to be most password attacks today are compromised with, where the attacker steals a file of passwords digest, and they compare that to their own digest they have created. Now, the offline passwords also include, the attacks also include a brute force attack, a mask attack, a rule attack, dictionary, rainbow tables, and password collections. The brute force is where they try every possible combination of letters, numbers, and characters that can be used to create encrypted passwords and match that against a stolen file. Now, this is the slowest, most thorough method. We also have a new technology land manager hash, where the attacker can steal the digest of the password and would of an NTLM password and would not need to try to break it. So from there, he just simply pretends to be the user and sends that hash to the remote system, which then is authenticated, and this is known as pass the hash attack. Okay, a mask attack is a more targeted brute force attack. This uses placeholders for characters in certain positions of the word, of the password. So the parameters here that can be entered in the mask attack include the password length, character set, the language, a pattern, or skips. A rule attack, what this does, it conducts a statistical analysis on the stolen passwords that is used to create a mask to break the largest number of passwords. So we see an example here of a rule attack statistical analysis. They look and say, okay, 62% of the passwords are at least 8 characters. 4%, 4 characters are 1%. They also have an advanced mask statistics, a rule attack generated mask. Okay, so they can find this information, the password information through this as well. All right, dictionary attacks. That's where the attacker creates a digest of common dictionary words, and they compare that against a stolen digest file. A pre-image attack is a dictionary attack that uses a set of dictionary words and compares it to the stolen digest. And a birthday attack is the search for any two digests that are the same. So we see here in the dictionary attack, I'm going to make this a little bigger so we can see this a lot easier. Okay, so we have our dictionary words here. Okay, they then created the digest. So we see our numbers, our digest here, dictionary word digest. And what they do is they take this and they compare it to the password digest. We see in this the YDUS and 6% 4 pound dollar sign does match up with the password digest. So they're able to go back and find the dictionary word to get the password. All right, rainbow tables, they create a large pre-generated data set of candidate digest. So what they do is they go in, they create the table, which is the chain of plain text passwords. They encrypt the initial password. They feed that function, feed it into a function that produces different plain text passwords. And they'll repeat this for a set number of rounds. They can use this to crack a password. So they run the encrypted password through the same procedures that they've used to create the initial table. And what this does, it results in the initial chain password. Okay, so they take this and they keep repeating it, and they start with initial password until the original encryption is found, and password is used at the last iteration as the correct password. So the last one is going to be the correct password. This does have advantages over other password attack methods. Once it can be used repeatedly, it's faster than the dictionary attack, and less memory on the attacking machine is going to be required. You can also get password collections. So in 2009, an attacker used SQL injection attack. And with that, they got more than 32 million users' passwords that were in clear text, and they were stolen. And what this did is it gave you two elements to the password for the password attacks. What it did is it gave the attackers a large corpus of real-world passwords. It also provided the attackers advanced insight into the strategic thinking of how users create passwords. So we can secure our passwords, and this is something that's going to be dependent upon the user as well as the enterprise or the organization. So the user involves properly managing your passwords. Doing things like don't write your password down, follow the, make your password complex, use different passwords for different systems. For the enterprise, it involves protecting the password digest. So when we're managing passwords, when we think of this, the most critical factor is going to be the length for a strong password. The longer the password, the harder it is for it to be cracked. Also, when you're looking at passwords, so in addition to having the long passwords, other recommendations: don't use passwords that consist of dictionary words. Don't repeat characters or use sequences. Don't use your birthdays, family members' names, pets' names, addresses, or any personal information. You can also use non-keyboard characters, and you can do this by holding down the Alt key while typing a number on the numeric pad. Can we see an example of the character map dialog box here? For this symbol here, they've got the keystroke of the Alt 0163. Okay, so that would add that character to your password. The pound sign for that. You can also use password managers. Now that's technology used for securing the passwords. We do have three basic types of password managers. You have a password generator, an online vaults, or password management applications. You can also protect your password digest by using salts, which what that does, that consists of a random string that's used in the hash algorithm. With this, passwords can be protected by adding the random string to the user's clear text password before it is hashed. And what this does, it makes the dictionary attacks and brute force attacks much slower, and it also limits the impact of the rainbow tables. Another thing you can do is use key stretching, which is a specialized password hash algorithm that is intentionally designed to be slower. We've got two key stretching algorithms, the BRYPT and PBKDF2. Now, when you're using salts and key stretching, you want to use a strong random number generator because you want to create a salt that's going to be at least 128 bits. You take that salt and the user's plain text password and you put this in the PBKDF2 algorithm. So then it's going to use the HMAC or the SHA 256 as the core hash. So once you hash this, it's going to perform at least 30,000 iterations on the PBKD F2. The first 256 bits of the output are going to be the password digest. I'm also going to store the iteration count, the salt, and password digest in a secure password database. Okay, so when we started this, we talked about the different types of authentication. What you know, what you have, what you are, where you are. And you can use these together to form a multi-factor authentication. So that's where you're using more than one type of authentication credential. So example is if you have a password, you type your password, that is what you know. But if you have a key card or a token, even your cell phone, okay, so you have a text message that sends an authentication code to your cell phone. So that's something you have. So you can use those two in combination to use multi-factor authentication. Single-factor authentication is just using one type of authentication. Our most common items used for authentication is our tokens, a card, or cell phones. Tokens are used to create a one-time password. Okay, and that password is only good for a limited period of time. Now, this can be something that can be a hardware token or a software token. Hardware tokens are going to be a small device with a window display. Most likely you'll have a button you'll push and it'll generate a code. Software may be something that's going to be stored on a laptop or a smartphone. So you have the time-based one-time password. Okay, these are synced with authentication servers. The code is going to be generated from an algorithm, and the code is going to change for every 30 to 60 seconds. You look at the one-time passwords. We got two types of those. You have HMAC-based one-time password, which is event-driven, and it changes when a specific event occurs. The advantage of using tokens over passwords is the token code changes frequently, which means the attacker would have to crack the code within the time limit. So if the code changes every 30 seconds, the attacker only has 30 seconds to break into the code. Also, if your password is stolen, you may not know it. But if a token is stolen, it becomes obvious, and you can take steps then to disable the account. So we have an example of the time-based one-time password, which in this case, the user uses the token. The code is 811314. So they enter their username and that password. When then the password is sent to the authentication server, where they look at the time and the date. And with this, they then verify that the code is matching to the code that's to the authentication server for the token. And so then they are allowed into the service they're requesting. All right, smart cards, they contain an integrated circuit chip that holds information. It can be either a contact card, which is a pad that allows electronic access to the chip contents. It could be a contactless card, a proximity card, which requires no physical access to the card, or it could be a common access card, which is something that's issued by the Department of Defense. And on that, it has a barcode, a magnetic strip, and the bearer's picture. This is an example of the smart card here. It does have the chip, and it's been able to be read by the pad. All right, cell phones are increasingly replacing token and cards. And this is what I was discussing earlier, where the code can be sent to a user's cell phone through an app on the device. It also allows the user to send requests via the phone to receive a one-time password authentication code. Next form of authentication is what you are. And this is dealing with biometrics. And we have something you are. Biometrics include your standard biometrics and also your cognitive biometrics. Standard biometrics are people using the people's physical characteristics for authentication. So this would be your face, your hand, your eye, fingerprints. Those are types of ways that standard biometrics are used to authenticate yourself. The way these work, the retinal scanner uses a human retina as a biometric identifier, and it maps the unique patterns into a person's eye using low beam energy infrared lights. Fingerprint scanners, you got two types of those. You got dynamic fingerprint scanner, which takes a picture and compares the image on file. The static does. The dynamic fingerprint scanner uses a small slit or opening. We see an example of a dynamic fingerprint scanner. Okay, so also with standard biometrics, you do have some standard input devices, which may be your voice recognition that uses the microphone to identify users based on the characteristics of a person's voice. The iris scanner will use a standard webcam, and also the facial recognition. Those will use landmarks on the human's faces for authentication. Disadvantages of using biometrics is the cost of the hardware scanning devices. And also the readers have some amount of error where it would reject an authorized user or maybe accept an unauthorized user as well. And they can also be tricked. Cognitive biometrics, these relate to perception, the thought process, or the understanding of the user. These are something that's easier for the user to remember because it's going to be based on the user's life experience, and it's going to be difficult for an attacker to imitate. One other thing is the picture password. Okay, this was introduced by Windows. What this did, it let the users select a picture to use, which they should be at least 10 points of interest that can be used to serve as landmarks or places to touch. Some other examples of cognitive biometrics maybe require the user to identify specific faces, or the user selects from several memorable events. All right, behavioral biometrics. This is what you do. This is the way a user is authenticated by normal actions that the user performs. One of the ways is keystroke dynamics, where it attempts to recognize the user's typing rhythm, because all users are going to type at a different pace, and this does provide up to 98% accuracy. It does this by doing two unique typing variables, using two unique typing variables. The dwell time, which is the time it takes to press and release a key, or the flight time. That's the time between the keystrokes. This does have a great amount of potential, and it does require no specific software. So we see an example of a typing template here, where the user's template is, and following along that range, that would verify the user, the approved user. We can see down at the bottom part where the attacker can't match up with the approved user. Another type of authentication is where you are, or geolocation. That's the location of a person or object using technology where it's able to be identified. Okay, so what this does is used most often to reject imposters instead of accepting authorized users. So it can indicate if an attacker is trying to perform a malicious action from a location different from the normal location of the user. And you guys may get this where it says you've been signed in to a different location. Did you sign in, and were you at this location? Many websites will allow a user to access an account if the computer is located in a different state. I'm sorry, not allow them to locate if to access it if the account is located in a different state. And it may require you have a second type of authentication if you're in a different location it's normally expecting you to be at. So it may send a code or a text message, a cell phone number. All right, a single sign-on. This is where this is dealing with identity management. So you use a single authentication credential and share across multiple networks. It's called federated identity management when the networks are owned by different organizations. And what this does, it helps reduce the burden of usernames and passwords that you have to memorize to just one. We currently use the single sign-on at GNTC as you log into your Blackboard account, your My GNTC account, your email, using the same information. All right, account management. When you're managing user account passwords, this can be done by setting up password rules. Now, with this can become too cumbersome to manage on a user-by-user basis. It's also a security risk if one user setting is overlooked. So to fix this, the preferred approach is to assign privileges by group or use a group policy. So a couple things you can set with the Microsoft group password settings. For example, you can set the password policy settings, account lockout policy. So if you try to log in, say 3 times unsuccessfully, you could be locked out for 30 minutes. Now you can set this up. So you set up the group policy, you set the rules for the password, the account for the group, and then you add the users to the group. Other things you can take is don't have a shared account, generic account, or guest account. Those should be prohibited. You also want to closely monitor any privileged accounts. You would disable account passwords instead of deleting accounts that are no longer being used. You also want to create strict policies regarding password recovery. Transit Trust is a two-way relationship that is automatically created between a parent and child domains in the Microsoft Active Directory for us. So with this, when a new domain is created, it's going to share resources with its parent domain by default. Now you can go in and enable and authorize users to access resources in both the child and the parent as well. All right, so chapter 11, we discussed authentication. Authentication is your username is saying who I am, and you would authenticate it is saying prove it. We can prove that by using something we have, something we are, something we know, somewhere we are. And there are many different types of attacks with on your password.